Okay, good evening, Professor David J. De Los Reyes. Okay, it's September 13, 2023. The time is 10:10 p.m. Okay, my topic for this session will be long video format discussion on college algebra, and this will now be lesson number 61. We are almost done with the college algebra, so we are running smooth. Okay, so let's proceed for the topic for tonight. The subject matter for tonight will be college algebra. This is now lesson number 61. We are running smooth. Okay. And the title of the topic is Variation Application Problems. The last time around, I discussed the different types of variation. That is the direct variation, okay, the joint variation, and the inverse variation. So for tonight, I will be presenting problems, okay, involving those concepts. Okay, example number one. I will try to read the problem. The drag force F on a boat varies as the weighted surface area A and the square of the boat's velocity V, victory, if the boat is going 65 kilometers per hour. Experience a drag force of 86 newtons when the surface area is 41.2 square feet. How fast must a boat with the surface area of 28.5 square feet weighted surface area go in order to experience a drag force of 94 newtons? Okay, let's try to analyze the problem. The best way to analyze the problem is to figure out the problem. There will be two conditions in the problem. There will be condition number one and condition number two. For condition number one, we got the boat. It's running on the water surface. And according to the condition of the problem, what's the condition of the problem? The drag force, okay, varies with the surface area, meaning the weighted surface area, okay, and the square of the velocity. There is a connective thing over here. It is N. The drag force F varies as the surface area, weighted surface area, and the square of the velocity. So this should fall under the so-called joint variation. Okay, they should fall under joint variation. Okay. Okay, I will go back to the figure. This will be condition number one. We are given drag force number one. Drag force meaning the resistance force as the boat, okay, slides atop the water line. This is drag force. And there's a velocity V. Okay. So for condition number one, we are given drag force number one. I still ang ganun. We are given the velocity and we are given the surface area. Surface area meaning the area that is submerged on water, weighted surface area. And for condition number two, okay, we are given drag force number two. Okay. We are given a surface area, new surface area, the weighted surface area. We are also given this one. So the problem is asking for the new velocity. Okay? So if we try to go back to the problem, okay, that's the figure and they should be given now. For condition number one, if the drag force is drag force or resistance force is 86 newtons, okay, the weighted surface area, capital letter A with the subscript 1 is 41.2 square feet. Capital letter B with the subscript 1, the speed of the boat, okay, is 65 kilometers per hour. For condition number 2, what will be velocity number 2? If the weighted surface area is 28.5 square feet, but the drag force is 94 newtons. The problem is asking what will be velocity number 2. Okay? So actually we are given 5 values. The 6th value or the third value on the second condition is unknown. But to solve the problem, we must have to bring out the equation. Okay? We'll make a representation first here. Capital letter F is the drag force. Capital letter A is the weighted area. Weighted is the weighted surface area, the one exposed to the water. And capital letter B refers to velocity. And the given condition of the problem is the drag force, okay, is varies with the surface area and the square of the velocity. Okay, so bring out now the solution of this one. Okay, we will be replacing this alpha here by a constant of proportionality. So F now will be equal to K, capital letter A times capital letter B square. If we try to compute for K, it will be F over area velocity square. So if on the given problem we are given condition number 1, so I will now place subscript number 1 here. And this should be equal to force over area velocity square for any given condition number 2. We are given the 3 values for condition number 1. We are given 2 values on condition number 2, so we can solve for the unknown. So substituting, F1 is actually 86 newtons. Okay, the area is 41.2 square feet. 41.2 square feet. The velocity is 65 kilometers per hour. We must have to square this one. Equal to. The new drag force is 94 newtons, so this is 94 newtons. Okay, the new surface area that is exposed to water is 28.5 square feet. Times, on this equation, this is the one we are looking for, the second speed at which the given condition 94 newtons in 28.5 square feet, okay, comes out. So solving for, this is now an equation, right? We are on algebra, so there's only one unknown. It's b sub 2. But the problem is it got a power 2. So we will, for the meantime, we will segregate new speed, quantity square. They should be equal to. We cross multiply this. So the right hand side will be the product 94 times 41.2 times the square of 65. The divisor will be the coefficient 28.5 and 86. Because this one goes with b sub 2 square. That's b sub 2 square. If we try to use our calculator, okay, what will come out, the, what you call this, if we try to simplify the numerator and denominator, what will come out will be, I tried this one already on my calculator, scientific calculator. That will be 6675.88. Okay, so b sub 2 now, that was b sub 2 square. So to compute for b sub 2, we must have to take the square root of this. Actually, it's like this. Square, right? No square root yet. So to compute for b sub 2, to take the square root of both sides. So if we try to take the square root of both sides, these two here will disappear. and this will now be with the square root. And the square root of 66.7 or 6675.88 is 81.70 kilometers per hour. So this will be our answer. Okay, so at least we now know how to solve a problem under variations. Okay, as always, we will bring out the given. We will be writing what is being asked. We try to figure out. Okay, we brought out now the solution. And to formulate the solution, okay, we will understand the concept and how the problem was introduced. It says the drag force is directly proportional to the surface area, weighted surface area, and the square of velocity. That's why it falls under joint variation. That's why our topic for tonight is variation application problems. Okay, so after the substitution and simplification, the new speed will be 81.70 kilometers per hour. Okay, example number 2. It's easy, right? Example number 2, this now refers to a problem under electrical engineering. That's my major subject. So I will try to introduce example number 2. The current I in an electrical conductor is inversely proportional to the resistance R. So there is a root word here, inversely. So this falls under inverse variation. Right? I will repeat it. The current I in an electrical conductor is inversely proportional to the resistance R. If the current is 0.5 amperes when the resistance is 240 ohms, what is the current when the resistance is 540 ohms? Okay, let's try to bring out obviously the problem is under inverse variation. Let's try to bring out first the given. Under condition number 1, the current capital letter I with the subscript 1 is current number 1. It's 0.5 ampere. Still for condition number 2. 1. Capital letter I with the subscript 1, meaning the resistance at condition number 1, it is 240 ohms. And we are to find for the value of I sub 2, meaning capital letter I with the subscript 2. Subscript 2, it now falls under condition number 2, the one in which the problem is being asked. And R sub 2, the resistance at condition number 2, this is with the subscript 2, 540 ohms. With the given condition, current varies inversely as the resistance. So there is R, right? So the inverse value of R is actually 1 over R. So it will be something like this. I is inversely proportional to R, meaning it should not only be R, it should be 1 over R for it to be pulled under inverse variation. Okay? Okay, let's try to bring out the picture. Oh, this is an electrical engineering problem. We are given two conductors. And on this conductor, the conductor has resistances, right? And with these resistances, a certain value of current will pass through the conductor. According to the given condition of the problem, initially, if the current is 0.5 amperes, okay, the resistance of the conductor is 240 ohms. Okay, that's the first condition. Next condition, the problem is asking for the current number 2. If the value of R, what's the value of R? It is 540 ohms. With the given condition, current varies inversely with resistance. So the key to the solution of the problem is by knowing the given condition that current varies inversely with resistance. So if we now try to bring out the solution, I will replace this alpha here, the constant of proportionality, by an equality sign, but we must have to introduce K. Okay? Since this is an inverse condition, it should be 1 over r instead of only r. It should be 1 over r because it is inverse. So if we now try to compute for k, k will be the product IR. So if we now try to solve for the unknowns, there should be a condition number 1, and there should be a condition number 2, and we could forget for the value of k. Because we have formulated already the equation and how to compute for the unknown. Okay? We are given conditions number 1. We are given condition number 2, except for the unknown. So substituting values. I1 is 0.5 ampere. R1 is 240. And they should be equal to I sub 2, meaning the current at condition number 2. This is for the second figure. That is when the resistance is 540 ohms. Again, we are now given a linear equation in which the unknown is not x, it's I sub 2. X and y is just a representation in the algebra. So computing for I sub 2, we must have to eliminate the number of I sub 2. We must have to eliminate this 540 here. So dividing both sides by 540, I sub 2 now will be 0.5 times 240 over 540. And what will come out is 0.222 ampere. So in here, the current should be 0.22 ampere. Oh, that's it. You know, guys, why certain why k is what's happening? I just put my new marker. From the equation k is equal to IR, this value here is actually voltage. Okay? In any electrical conductor, voltage is the product of current times resistance. So this key here is actually voltage. That's electrical engineering. Okay? That's where voltage is equal to IR was derived. Right? Voltage is equal to IR, right? For DC circuit. For impedance or for AC circuit or transformers or AC machines, voltage is equal to IZ. It's the same. Z for AC circuit, R for DC circuit. So this is actually a DC circuit problem. Okay, that's it, guys. This is two example problems on the concepts of variation. First one is joint variation. Second one is inverse variation. Okay, this is Professor David J. Dos Reyes. Good evening from Los Angeles.